Example 3. A window is being built, and the bottom is a rectangle, and the top is a semicircle. If there is 12 meters of framing materials, what must the dimensions of the window to let in the most light? Okay, so the picture is given and the variable are given. Okay, so what is our goal? To let in the most lines. Okay, so let in the most lines means we want to maximize the area so that we can get most lines, right? Okay, so we also have information 12 meters of framing materials. So what is that 12 meters? Well, that is the perimeter of the window. Okay, what is the perimeter? We have 2r. And we have, this is h, this is another h. So we have 2h. Okay, and we also have a semicircle. So the semicircle, we know the circumference of a circle is 2 pi r. So semicircle is pi r, right? And that equals to 12 meters. Next, we want to write the relations. Okay, so what is area? Well, we have a rectangle, so that's length times width. So 2r times h. And then we have the semicircle, which is half of the area of a circle, pi r squared. Okay, everybody? So let's continue. Well, this is a function of two variables, r and h. Well, we need a function of one variable, so we need to eliminate one of them. So how do we do that? Use this information. Okay, so we either express h in terms of r or express r in terms of h. I think express h in terms of r is easier because we have only one h, but we have two r there. Okay, so what is h? Well, 2h is then, we move the r to the other side, so 12 minus pi r minus 2r. So h is divided by 2, so 6 minus pi over 2r minus r. That's h, so plug in here. So we have 6 minus pi over 2r minus r plus 1/2 pi r squared. Okay, so now we can distribute it. So we have 12r, and then we have 2 cancel, we have pi r squared. And then we have minus 2r squared plus half pi r squared. Okay, let's combine the like terms. So we have 12r and we have minus 2r squared. But you can see we have minus pi r squared and the plus half pi r squared. When we combine them, we get negative half pi r squared. So that is our a. And it is a function of one variable. So we're ready to differentiate. So when we differentiate, what do we get? So we get the derivative of 12r is 12. The derivative of 2r squared is 4r. The derivative of r squared is 2r, so 2 and 2 cancel. We have pi r. Do you get that? And we set it equal to 0. Remember, to find maximum minimum, we take the derivative, set it equal to 0, and then we find the critical point. Alright, let's solve for r. So here, can you see these terms have r, so let's factor it. We can have 12 minus r, and this is 4 plus pi when we factor it, right? We can then move r to the right hand side, so we have r 4 plus pi on the right. So r is 12 over 4 plus pi. Okay, So that is our R. Do you know what is the next step? Next step is to find the domain. What's the domain of R? How small can R be? Well, it could be 0, right? If R is 0, your window is like just like a two line segments, like that, okay? And each of them is like 6 meters. Okay, how big can R be? Well, your biggest R is when your H is 0. So your window is just like this shape. Well, okay, we know the framing material is 12, so this is 2R, and that guy is pi r. So we have 2R plus pi r is 12. Okay, so that's why we have R is 12 over 2 plus pi. So this is the biggest it can be. Let me draw this picture in the lower, so then we have more space. Okay. All right, so that's why the biggest is 12 over 2 plus pi. This is the biggest. Okay, biggest R. Okay, is that. Okay, so we're ready. We draw the diagram. So we have 0 and we have 12 over 2 plus pi. And 12 over 4 plus pi. You can see this guy, the numerator is bigger than this denominator. So if the denominator is bigger, then the number is actually smaller. Okay, so we have A prime and A, because this guy is a critical point. So A prime evaluates at that point is 0. Okay, and then we look at this, the other pieces, we want to see whether it's positive or negative. So let's see. Okay, where's my... Okay. All right. Okay, so I cannot change my color. It's okay. So we plug in 0 into A prime. This is A prime. Okay, when we plug in 0, we get 12. So 12 is positive. And then this guy, imagine, is a big number. So 12 minus some big number is going to eventually be negative, right? So A is then increasing, decreasing, you get maximum, right? So we actually get maximums when the R is 12 over 4 plus pi. And the H, what is H? Well, H is this guy, right? So H is 6 minus pi over 2. R is 12 over 4 plus pi minus R, 12 over 4 plus pi. Okay, so you can leave it like that, or you can put this in your calculator. All right. So that is example 3. Okay, so how about example 4? Okay, so example 4, a man launches his boat from point A on the bank of Street River, 3 kilometers wide, and wants to reach point B, 8 kilometers downstream on the opposite bank, as quickly as possible. If he can row 6 kilometers per hour and run 8 kilometers per hour, where should be land to reach point B as soon as possible? All right, okay, so this is the picture. All right, so let me make sure the word is working. So our goal is to reach point B as soon as possible. As soon as possible means we want to minimize the time. Okay, so how do we minimize the time? So let time be t. Okay, and we know that time equals to distance over speed. Okay, so now let's see. We want to know where should it land. So let's call this guy bx. Okay, let's call this guy bx. Then can you see that there are some there are two triangle? Okay, so there is a triangle ACD and a triangle ACB. Okay, so we know time is distance over speed. We know the speed. So the person can roll 6 kilometers per hour and run 8 kilometers per hour. So let's figure out, so time is the time on the river plus time on the land. Okay? And then, so time on the river is the distance on the river. Okay, so distance on the river over the speed on the river, that is 6. And the distance on the land, okay, over the speed on the land, so he runs 8 kilometers per hour. Okay, so what's distance on the river? Well, then here we look at, let me use different color. So we look at the triangle ACD. This is x, this is 3. So actually the distance on the river is AD. Okay, so what is AD? Well, square root of x squared plus 3 squared, that's 9. So we have square root of x squared plus 9 over 6. So far, so good. And how about the distance on the distance on the land? So on the land, we have this 8. Okay, so on the land is actually BD. So this is BD. Okay, so on the BD, we know this total CD is 8. Then BD is 8 minus x. And then the speed is 8. So this is the time. This is total time. Let's simplify it before we differentiate. Okay, so this guy is 1 over 6. X squared plus 9 to the 1/2. And then here we can split. So 8 over 8 is 1. And then we have x over 8. Okay, so time is the t. So now we see is a function of one variable. Okay, so we are ready to take the derivative. So t prime of x is then 1/6 times 1/2. And then x squared plus 9. So this is like chain rule. U to the 1/2 derivative is u to the minus 1/2 times u prime. But what is u prime? Okay, it's this. And then the derivative of 1 is 0. Derivative of x over 8 is 1 over 8. So actually this guy is 2x. Okay, so that's why here we have 1 over 6, 1 over 2, x squared plus 9 to the minus 1/2 times 2x minus 1/8. So 2 cancel. Okay, let's rewrite it. If you see a factor with negative exponents, that means it lives in the denominator. So it lives in the denominator. And the numerator is x minus 1 over 8. Okay, everybody? So we either take the common denominator and try to factor it, but here, because this is quite complicated, let's set it 0 here and solve it here. Okay, so we set it equal to 0. To solve for x, well, we can move the 1 over 8 to the other side. And then you cross multiply. Okay, cross multiply. We get 8x equals to 6 square root of x squared plus 9. And then what do? Can you see a common factor 2? So both sides divided by 2, we get this one. And when you see square roots, get rid of the square roots. How do we get rid of the square roots? We square both sides. So we have 16x squared. And here we have 9. Square roots of square cancel. So we have x squared plus 9. Let's distribute it. So 9x squared plus 81. Okay, let's move the 9x squared to the left. And we get 7x squared. Because 16 minus 9 is 7. And so x squared is 81 over 7. X is square root of 81 over 7 plus or minus. So we get plus or minus square root of 81 is 9 over square root of 7. But here, your x is positive because you don't go backwards and come here, right? So that's why we only pick the positive number. So x equals to 9 over square root of 7. Okay? So that is our critical point. What is the domain? Okay. All right. So the domain is how small can x be? 0, right? So 0 means you just go across and then go this way. Okay? So how big x can be? I would say 8 is like here. You just go straightly on the river, okay? Through the river. So that is our domain. Okay, let's draw the diagram. 0 and 8. And 9 over square root of 7 is in between. So we want to know t prime and t. We know at 9 over square root of 7, this is the critical point. And the t prime is 0. How about at 0, what do we get? At 0, the first factor is 0, and then minus 1/8, so it's negative. How about when it's 8? You can put it in your calculator, and you will see that is positive. So that's why t is decreasing and then increasing. This is actually minimum. Okay, do we want to find minimum? Yes. So actually the problem already tell you we want to find minimum, right? So we want to minimize the time. So you draw the diagram is actually just verify our answer. Okay? And it makes sense. We get minimum. So we get minimum time when the x equals to 9 over square root of 7 kilometer. Okay? So that is example 4. Okay. Next, let's look at example 5. A rectangular garden is built with one side against a barn. 200 meters of fencing are used for the other 3 sides of the garden. Okay, what dimensions maximize the area of the garden? Okay, so we have one side is the barn, okay, and we just need to build the other 3 sides. Okay, so it's a rectangular garden. Okay, and so let's say this is y, this is y, this is x. Okay, so this is how we set it up. And what do we need? So what information do we have? 200 meters of fencing. Fencing is the perimeter, okay? So actually, because here we only need to build 3 sides. So that's why 2y plus x is 200 meters. Okay, what is our goal? We want to maximize the area of the garden. Okay, so what is the area of a rectangle? x times y, yeah, but it's a function of two variables. What do? We have to get a function of one variable. So use some information to eliminate one of the variable. Okay, so from here, maybe using x is easier. So it's 200 minus 2y. Okay, that is x. So we're ready to plug it in. We get 200 minus 2y times y. So that is our a. Okay, but because next steps we're gonna take the derivative, we don't want to do product rule here, so let's distribute it. So then we just need to do power rule. Okay, so ready, a prime of y is 200, y prime is 1, minus 2 times 2, 4y. Okay, so this is our derivative, and we set it equal to 0. Okay, so what do we get? Well, we get 200 equals to 4y. Y is in fact 50. Okay, so y is 50. Let's think about the domain. How small can y be? Well, it could be 0, right? If it's 0, then you only have x. You don't have any y. Okay, how big can y be? Well, the biggest y is just you only have the y, you don't have the x. So you use all the materials to build a y. So it means 2y is 200. Okay, that means y is 100. So this is the biggest it could be. Okay, so let me use this picture, see whether you can understand. Okay, so that's why we draw a diagram. We have 0 here, and we have 100 here, and 50 is in between. Okay, we want to do a prime and a. Okay, a prime. We know y is 50, and that is the critical point. So a prime is 0 here. And then on the outer intervals, okay, we want to pick a point here, but 0 is here. So let's plug in a prime. We plug in 0, we get 200. 200 is positive. And when we plug in 100, we get 200 minus 400 is negative 200. So we get negative. So that's why a is increasing and then decreasing. Then this guy is the maximum. Do we have maximum? Are we asking maximum? Yes, we want to maximize the area. So now it match with our goal. So we get maximized area when the y is 50. And when the y is 50, what is the x? Well, x is 200 minus 2y. So y is 50, so 200 minus 100 is 100. Okay, so that is example 5. Okay, so next we have example 6. Okay, let me see whether the drawing function. Oh, still not working. Okay, I'm so afraid it freezes. Then I need to write the note again. Okay, example 6. A rancher plans to make 4 identical and adjacent rectangular regions against a barn, each with an area of 100 meters squared. What are the dimensions of each region that minimize the amount of fence that must be used? Okay, so we have a barn right here, and we want to make 4 identical and adjacent rectangular regions. So 4 regions. Right, so 4 identical adjacent rectangular region against a barn, each with an area. So each with an area of 100. So each of them, the area is 100 square meter. Okay, meter square. So what are dimension of each region that minimize the amounts of fence that must be used? So let's call this be y and let's call this be x. I mean, this guy is x. Okay, so this is the dimension of one region. All right, so we know that because the area of each region is 100, so we get x times y is 100. Okay, so our goal, what is our goal? Is to minimize the amount of fence. Okay, so let's say the amount of fence is f. So what is f? Well, how many y are there? So 1, 2, 3, 4, 5. We have 5y. Okay, so 5y. How many x are there? 1, 2, 3, 4. So 4x. So that is my f, right? Okay. So this is a function of two variables, so we need to use the information to eliminate one of the variable, but here the difficulty are the same. So maybe let's do y to be 100 over x. Okay, we solve y in terms of x. Okay, and here 5y, so 5 times 100 over x plus 4x. Okay, so that is 500 over x plus 4x. Okay, now what is f prime? So f prime is then derivative of 1 over x. So make it into the standard form. This is like 500 times x to the minus 1. So it's minus 1, 500 x to the minus 2, plus the derivative of 4x is 4. Okay, so this is minus 500 over square plus 4. Okay, remember every time you see x with a negative exponent, that leaves in the denominator. So you have to put it down, and then you know there's a quotient to take the common denominator. So we have minus 500 plus 4x squared. Okay, this is a quotient. How do we find critical points? We make the numerator 0 and the denominator 0 to find the critical points. So here 4x squared is 500, x squared is 125, right? Then x is square root of 125. 125 is actually 5 cubed. So this is like 5 and square root of 5. Or x is 0. Okay, so what is the domain of x? What is the domain of x? So domain of x, well, the smallest x is 0, but not really. You cannot reach the 0, because if you reach the 0, you won't have the region, you won't have the, let's say, the area is going to be 0 when x is 0, okay? You don't have a positive area for the region. And how big can x be? Well, can be very, very big. It's just gonna, your y is just gonna be small, okay? So we draw our domain from 0 to infinity, and then the 5 square root of 5 is there. So we want to know f prime and f. Well, at 5 square root of 5, because it's how do you get this number? You get it from the numerator is 0. So the numerator is 0 when the derivative is 0. Okay, and then this piece, you can pick a number, you can plug in 1. 1 is in here. So we can plug in 1 into our f prime. So we plug in 1 minus 500 plus 4 is negative. The bottom is always positive, so the answer is negative. And think about it, here you can pick x to be a very big numbers, then 4x squared minus 500 is going to be positive, and the denominator is always positive. All right, and so now we can see f prime negative, so f going down, f prime positive, f going up. So this is actually a minimum. Are we looking for a minimum? Yes, we want to find the minimum. So we get minimum amount of fence. Okay, amount of fence when x is 5 square root of 5. Okay, that is x. Then how about the y? Well, the y is 100 over x. So 100 over 5 is like 20. 20 over square root of 5. You know, 20 is like 4 times 5. So that's why it's 4 times square root of 5. Because 5 over square root of 5 is square root of 5. Okay, so now we get the dimension for x and y. All right, so if you have any questions, feel free to email me or visit our online office hours. All right, bye.